3-eye atlas updates, and maybe even our best shot yet to clearly see the third interstellar object.
Is that we see an image very similar to the Hubble Space Telescope image that was obtained on July 21st.
A perfect glowing cylinder just drifted across the Martian sky.
As one Harvard professor is raising the theory, this may actually be a piece of alien technology.
Captured by NASA's Perseverance rover on October 4th, 2025. Just pure structure moving at 134,000 miles per hour through our solar system. This isn't your typical space rock. This is 3-eye atlas, the fastest interstellar visitor we've ever recorded. And it's displaying behavior that's challenging fundamental assumptions in planetary science. The object appears 28.6 miles wide, yet weighs over 72 trillion pounds. That's equivalent to compressing 10,000 Empire State Buildings into the volume of a city block. But here's what's really got everyone talking. When Harvard astrophysicist Avi Loeb analyzed the rover's image, he discovered something that challenges everything we thought we knew about this mysterious visitor from beyond our solar system. If you're fascinated by space mysteries and want to stay updated on the latest cosmic discoveries, hit that subscribe button. We're diving deep into the universe's biggest puzzles. 3-eye atlas didn't just enter our solar system through conventional means, it arrived at velocities that defy conventional comet behavior. Discovered on July 1st, 2025, this interstellar object is moving nearly twice as fast as the previous record holders, Oumuamua and Comet Borisov. We're talking about an object that could travel from New York to Los Angeles in just 90 seconds. But speed isn't the only thing that makes 3-eye atlas extraordinary. Its hyperbolic trajectory proves it originated from deep space, somewhere beyond our solar system's influence. Unlike regular comets that follow predictable elliptical orbits around our sun, 3-eye atlas is on a one-way passage through our cosmic neighborhood. It came from the void, and it's heading back to the void, never to return. On October 3rd, 2025, something unprecedented happened. 3-eye atlas made its closest approach to Mars, passing within 18 million miles of the red planet. For the first time in human history, we had multiple robotic observers positioned to capture an interstellar object from different angles simultaneously. NASA's Perseverance rover, positioned on the Martian surface, became our primary observation platform for this cosmic event. The European Space Agency deployed both Mars Express and the ExoMars Trace Gas Orbiter to track the visitor from orbit. Even the Mars Reconnaissance Orbiter with its powerful HiRISE camera joined the observation campaign. But it was Perseverance's right navigation camera that captured the image everyone's talking about. At 21:33:39 local Mars time on October 4th, the rover photographed what appeared to be a bright cylindrical object streaking across the Martian sky. When the image hit social media, the internet exploded with speculation. The object appeared as a perfect glowing cylinder. No irregular comet-like shape, no visible coma or tail, just a clean, structured form moving through space. Amateur astronomers and space enthusiasts immediately began asking the hard questions. If this is supposed to be a comet, where's the characteristic dust and gas trail? Why does it look so artificially perfect? Some even suggested it might be an alien mothership. Here's where things get really interesting. Dr. Avi Loeb, the Harvard astrophysicist who's never afraid to challenge conventional thinking, conducted a detailed analysis of Perseverance's photograph. His investigation reveals the true story behind that mysterious cylindrical shape. The Perseverance rover's navigation camera has an angular resolution of 0.33 milliradians per pixel. At 3-eye atlas's distance of 23.6 million miles from Mars during the photo session, this translates to a spatial scale of about 7,800 miles per pixel. The elongated stripe in the image measures approximately 31,000 miles in length. But here's the crucial detail that changes everything. 3-eye atlas has an estimated maximum diameter of only 28.6 miles. The object in the image is over 1,000 times longer than the actual comet could possibly be. So what created this perfect cylindrical illusion? The answer lies in photographic technique and the incredible speed of our interstellar visitor. The Perseverance rover didn't capture 3-eye atlas in a single snapshot. Instead, the navigation camera stacked hundreds of images over approximately 10 minutes of observation time. During those 10 minutes, 3-eye atlas was racing across the Martian sky at 25.8 miles per second relative to Mars. Think of it like trying to photograph a speeding bullet with a long exposure. The bullet would appear as a bright streak across your image, not as the small, round object it actually is. That's exactly what happened with 3I Atlas. The long integration time created an artificial elongation as the comet moved across the camera's field of view. To prove this theory, scientists compared the Mars rover image with Hubble Space Telescope observations taken on July 21, 2025. If 3I Atlas were actually 31,000 miles long, it would have appeared as a massive streak in Hubble's much more sensitive images. Instead, Hubble showed 3I Atlas as a small, point-like object, exactly what you'd expect from a 28.6-mile-wide comet at that distance. The Hubble images confirmed that the cylindrical appearance was purely an artifact of the rover's imaging technique, not evidence of an alien spacecraft. Even though we've solved the cylindrical mystery, 3I Atlas continues to present significant scientific challenges with its unusual characteristics. The object's mass-to-size ratio is completely off the charts. At 72 trillion pounds packed into a 28.6-mile diameter, this object demonstrates extraordinary density for what should be a typical icy comet. Traditional comets consist primarily of frozen volatiles, loose collections of ice, dust, and rock, with relatively low density. But 3I Atlas appears to have the density of solid rock, or even metallic composition. This represents a fundamental deviation from expected comet characteristics. The object is also releasing gases in patterns that don't match normal physics models for comet behavior. As it approaches the sun, it should be heating up and releasing water vapor and other volatiles in predictable ways. Instead, 3I Atlas is outgassing at rates and compositions that contradict established models. What this means for our understanding of space? I Atlas represents something fundamentally important for astronomy. This is only the third confirmed interstellar object we've ever detected passing through our solar system. Each one teaches us something completely new about what exists in the vast spaces between stars. The fact that we can now coordinate observations from multiple spacecraft, rovers on planetary surfaces, orbiters around different worlds, and space telescopes gives us unprecedented ability to study these rare visitors. We're essentially building a solar system-wide observation network. The 3I Atlas observation campaign showcases how far our space technology has advanced. Perseverance's cameras can detect objects millions of miles away with enough precision to track their movement across the sky. The Mars Reconnaissance Orbiter's high-rise camera achieved a resolution of 18.6 miles per pixel when imaging 3I Atlas. That's like being able to see a football field from 1,000 miles away. This technological achievement opens up possibilities for future discoveries. As we place more advanced instruments throughout the solar system, we'll be able to study interstellar visitors with unprecedented detail. 3I Atlas won't be visible from Earth again until later this year, but its closest approach to our planet will be a safe 170 million miles away. That's over 4 times the distance between Earth and the Moon. There's absolutely no danger to our planet, but the opportunity for continued observation remains incredible. Scientists are already preparing for the next interstellar visitor. With improved detection networks and coordination protocols between space agencies, we'll be ready to capture even more detailed observations of these cosmic wanderers. What makes 3I Atlas truly special isn't just its record-breaking speed or mysterious density. It's what this discovery represents for humanity's growing capability to explore and understand our universe. We've gone from barely detecting these objects to coordinating multi-spacecraft observation campaigns across the solar system. Every time an interstellar visitor passes through our cosmic neighborhood, we get a direct sample of what exists in the deep space between stars. These objects carry chemical signatures and physical properties that tell us about stellar formation, planetary system evolution, and the distribution of matter throughout our galaxy. The perfect glowing cylinder that captured everyone's imagination turned out to be a photographic artifact. But the real 3I Atlas is far more fascinating than any alien spacecraft theory. It's a messenger from interstellar space, carrying secrets about the birth and death of stars, the formation of planetary systems, and the incredible diversity of objects drifting through the cosmic ocean. As we continue to push the boundaries of space exploration and develop more sophisticated detection and observation technologies, Visitors like 3i Atlas remind us that the universe is full of surprises waiting to be discovered. Each new interstellar object teaches us something completely unexpected about the cosmos we call home. If this deep dive into 3i Atlas has sparked your curiosity about space mysteries, smash that like button, subscribe for more cosmic discoveries, and drop a comment below telling us what space mystery you'd like us to tackle next. And hey, if you know someone who loves space as much as you do, share this video with them. They'll thank you for it.